Hello everyone. Today we will start to discuss CBSE class 10th maths board examination question paper, and here is the question paper series, and this is the question paper code 30 by 2 by 1, and this is set 1. So as we know, in this question paper we have 5 sections, so we will start to discuss one by one. At first we are starting to discuss section number A. And in section A, all the questions are MCQ. So let's start to discuss question number 1 at first. Okay, so this is question number 1. And in this question, we have to find LCM of two given numbers. One number is 960 and another is 240. So how we can find LCM, that we know. If two numbers are given, then we have to divide to get the LCM. We have to divide the given numbers at first by their common factors. Here, one thing I can see very easily, that 24 4s are 96. 24. If we multiply by 4, then we will get 96. 4 4s are 16. 6 and carry 1. So 4 2s are 8 plus 1 9. So look at here. 96 is divisible by 24 and quotient will be 4. That means 960 is also divisible by 240. So if we divide both the number by 240, then here we will get 40 and here we will get 1. Okay. So that means, sorry, this will be not 40, this will be actually 4. As this, the given number is 240. So 244 is a 960. So here will be 4 in quotient. And that means this is the only common factor here, as we have divided by 240. So what rest here, what left here, 4 and 1. That means what will be the LCM? LCM will be product of these factors, 240 multiplied by 4 multiplied by 1. And this is 960. So the LCM is 960. But one thing I want to tell you, that if we have one collection of numbers and we want to calculate LCM of those numbers, then if the largest one is divisible by rest of the numbers, then we know that largest one will be the LCM. Here, among these two numbers, 960 is divisible by 240. So if we can observe this, then no need to find this LCM by prime factorization and all this. No need to write, because in MCQ we don't have to show the process. We have to find the answer only. So as the largest one, 960 is divisible by 240. So directly we can say the largest one will be the LCM. That means 960 is the correct answer for this question. So we will solve now question number 2. Okay. So what is question number 2? What is given here in question number 2? In question number 2, the natural number 1 is a prime number, a composite number, prime as well as composite, and neither prime nor composite. So to identify the correct option, we have to know here definition of prime and composite numbers. So what is the definition of prime number? If any number is divisible by 1 and itself, then we can say that number is prime. And if any number is divisible by uh, 1 itself and by other numbers, that means more than two factors are there if for any number, then that number is composite. Like for example, 2. Which are factors of 2? 2 we can divide by 1 and 2. So these are only two factors. So this number is divisible by 1 and 2 only. Okay, 1 and itself. That means 2 is prime number. What about 3? 3 is divisible by 1 and 3. So here also this number is divisible by 1 and itself. So this is also prime. But what about 4? 4 is divisible by 1, 2 and 4. So it is divisible by 1 itself and another factor we are getting here, except these two. So this is not prime, this is composite number. Okay, so these are definitions. So if you observe one thing, for all the prime numbers, number of factor is always 2, 1 and itself. But for composite numbers, other factors are there except 1 and itself. That means more than 2 factors are there for composite number. But what about 1? For 1, only one factor is there, no? That is 1 itself. That's why it is not satisfying the criteria of prime. That means there is no two factor and there is not two factors, and also it is not satisfying the criteria of composite. Like composite numbers have more than two factors. So that's why one is neither prime nor composite. Okay. So this we can solve by only knowing the definition. And let us move to question number three. Question number three. What is given in question number three? In question number three, for any natural number n, okay, for any natural number n, 5 to the power n ends with the digit. That means the ending digit we have to find. Ending digit means the unit digit. So let's check. We don't know value of n is in n is arbitrary number, arbitrary natural number. So let us check. At first, put some natural numbers in power of 5. Okay. So in place of, as these are natural numbers, in place of n, we can put natural numbers. So if we put 1 here, what will be value of this? 5 to the power 1 is 5. Next natural number 5 to the power 2, 25. Next natural number 5 to the power 3, it is 125. Then next is 625. So we can proceed in this way. So observe one thing. What is the unit digit here in these powers? In first one, 5 is the unit digit. In second one, again 5 unit digit. In third one, again 5 unit digit. So again and again, in the product we are getting in the product in unit digit we are getting 5. Okay, for the next power again we will multiply it by 5 na. What we will do for 5 to the power 4, 125 we will multiply by 5 digit, sorry, 5 we will multiply by 5. So what will come in the unit digit, we have to observe that only. We are not interested about the product. We have to observe the unit digit only. Okay, so again for the next power we will multiply 125 by 5. That means in unit digit 5 multiplied by 5, so 25, that means again 5 will come. It's clear. No need to find rest of the digits. Okay. We have to find only the unit digit. So here we are getting one pattern. As for the unit digit, we will multiply 5 by 5 again and again. So only 5 will come in the product. That means for all the powers of 5, we will get 5 in the unit digit. So the correct answer is 5. Okay. So we are moving to the next question. Next question. For the next question, here one diagram is given. At first, let's observe the diagram. Well, the graph of y equals to fx is given. The number of distinct, note it, distinct zeros. We want to find distinct zeros of y equals to fx. Okay. So if we don't know the function, that means if we have the diagram of the function only, then how we can find number of zeros? Okay. So for that, we observe only that the function how many times intersecting the x-axis. Okay. Now it can intersect in two ways. Okay. One like this. That means at first the value of fx is positive, then it is intersecting x-axis at some certain point. Then the value is changing to negative. This is one way. And another way is the value remains same after intersection like this. If the function intersects in this way, x-axis, that means before intersection, the value is positive. Again, after intersection, value is positive. Value is same. Not the value, actually, sign of the value is same. In this case, there will be repeated zero. In this case, there will be repeated zeros at the point of intersection. That means before intersection and after intersection, sign of the value of function remains same. In that case, there will be repeated zero. And if the sign changes after intersection, then there will be what? Single zero. Single zero. Okay. So according to that, here at first in left side of origin, value of the function is negative as it is below x-axis. And here it intersects x-axis, and after that the value became positive. Okay, that means here is 1 0, as here the function is intersecting x-axis. What about later? After that, here in left side of this intersecting point, the value is positive as it is above x-axis, and here it intersects x-axis. And after that, again the sign is same, positive. Sign of the fx is positive. So sign remains same after the second intersection. That means here is repeated zero. But we are not interested about that. As in the question, we want to find distinct zeros. So here is 1 0 and here is another 0, which can repeat. But we want to find only distinct zeros, no? So how many distinct zeros we got? 1 and 2. Two distinct zeros. Repetition we are not considering. Clear? Let's move to the fifth question. Okay. So this is question number 5. In this question, it is given that alpha and beta, these are zeros of this given polynomial. Fx equals to px square minus 2x plus 3p, and value of alpha plus beta is equal with alpha multiplied by beta. So we have to find value of p by using all these given information. Okay. So some results here we will use. At first, let me write the result. If ax square plus bx plus c equals to 0. This is one quadratic equation, and if alpha and beta are roots of this given equation, then these roots are related with these coefficients of the variable, like coefficient of the first term, coefficient of the second term, and the constant term. How they are related? Sum of these roots, that means alpha plus beta, this will be equal with minus b by a, and product of the roots, that means alpha multiplied by beta, this will be equal with c by a. So at first, to solve this question, we need to know these two results. Okay, we will apply these two results here to solve this question. That means sum of the root will be equal with minus coefficient of the x by coefficient of x square, and product of the roots is equal with constant term by coefficient of x square. Okay. Now this equation we will compare with the given fx. Here coefficient of x square is p, and minus 2 and 3 for rest of the rest terms. Okay. So alpha plus beta, according to the result, it will be equal with minus. Now coefficient of x. What is coefficient of x here? Minus 2. So let us put this minus 2. Then coefficient of what will come here in the denominator? X square, which is p. So if we simplify, 2 minus signs are here. So if we multiply, it will be equal with 2 by p. By the first solution, we are getting this. And what about the product of roots, alpha and beta? This will be equal with constant term. What is constant term here? 3p is the constant term. So 3p by coefficient of x square, which is p. So p and p will cancel out. So what left? 3. Okay. So this is the value of alpha beta. Now one relation is given that alpha plus beta is equal with alpha multiplied by beta. So this is value of alpha plus beta, and this is value of alpha multiplied by beta. So to put this in the given relation, that means in LHS alpha plus beta, it is nothing but 2 by p, and in right side alpha beta, which is 3. Then what will be the value of p from this relation? If we cross multiply, then p will be equal with 2 by 3. So which option is this? This is option B. So option B is the correct answer. P value is 2 by 3. So in this way, in next videos, I will solve rest of the MCQs and next sections also. So if you like these solutions for this kind of videos, don't forget to like, share and subscribe my channel. Thank you.